In this video, we're going to take a look at exponential functions. So let's start by taking a look at the laws of exponents. So if we multiply two exponentials together and their bases are the same, so number one, we have b raised to the x times b raised to the y. We add the exponents. And two, when we divide b raised to the x divided by b raised to the y, we're going to subtract the exponents. So the base stays the same, and then we only work with the exponents. Now when you raise an exponent to an exponent, like in 3 we have b raised to the x all raised to the y, we multiply the exponents. In 4, if we have ab all raised to the x, we can rewrite that as a to the x times b to the x, and the same for the division in 5. So let's take a look at a couple of examples of how this works. So in a, I have 5x squared all squared times negative 2x to the negative 1. So the first thing that I want to do is take care of this exponential outside the parentheses. Now you need to make sure you square both terms inside the parentheses. So we have 5 squared is equal to 25, and then we have x squared squared, and remember, when we raise an exponent to an exponent, we multiply the exponents. So we have x to the 4 times negative 2x to the negative 1. And now we want to multiply our like terms. So we have 25 times negative 2, so we multiply our constants together. And then we have x to the 4th times x to the negative 1. And because we're multiplying them, we add the exponents. So we have 4 minus 1, or x to the 3rd. In b, we have a division. So we have 2x to the 3rd, y to the negative 1, all divided by 4, x to the negative 1, y to the 3rd. So the first thing that I'm going to want to do is divide all of the variables that are similar. So I have 2 divided by 4, so that's going to give me a 2 in the denominator. And then we have x to the 3rd divided by x to the 1. And remember, when we divide, we subtract the exponents. So we have x to the 3rd divided by x to the negative 1 is x to the 3 minus a negative 1, or x to the 4th. And now we have y to the negative 1 divided by y to the 3rd. So I have negative 1 minus 3 is y to the negative 4th. And we don't want to leave our answers with negative exponents, so remember, if the exponent is negative in the numerator, it becomes positive in the denominator. So we have x to the 4th divided by 2y to the 4th. Let's take a look at some other examples. Here we want to solve for x. So I have in a 2 raised to the 3x minus 7 is equal to 2 raised to the 8th. Remember, if the bases are the same and we want this expression to be true, then we're just going to set the exponents equal to each other. So we're going to say 3x minus 7 is equal to 8, 3x is equal to 15, and x is equal to 5. In b, we have an example where the bases aren't the same to start. So we have 3 raised to the negative x squared is equal to 1 over 81. So what I want to do is rewrite it with the base being the same. So I'm going to say 3 to the negative x squared is equal to 1. Now we can write 81 as 3 to the 4th, and then we're going to move it to the numerator. So we have 3 to the negative x squared is equal to 3 to the negative 4. So now we have the bases are the same. They're both 3. So now we can say negative x squared is equal to negative 4. Multiply both by negative 1, giving me 4 on the right. And now x is equal to 2, and x is equal to negative 2. In this last example, we want to solve this for x, and we have 2 times 2 raised to the 2x minus 10 times 2 raised to the x plus 8. And what I'm going to want to do is create a form that we do know how to solve. So we're going to have to use a substitution, and before I do the substitution, I want to rewrite this one time, and I want to say 2 times 2 to the x all squared minus 10 times 2 raised to the x plus 8. And now we're going to use a substitution to make this look like a quadratic. So I'm going to say u is equal to 2 raised to the x, and then I can rewrite this as 2u squared minus 10u plus 8 is equal to 0. And then I'm going to factor a 2 out, so I have u squared minus 5u plus 4 is equal to 0. And now I can write this as factors as 2 times u minus 4 times u minus 1 is equal to 0. So u is equal to 4 and u is equal to 1. And now we solve for u, but we need to solve for x. So what we're going to do is write 4 is equal to 2 to the x and 1 is equal to 2 raised to the x. And now for 4 is equal to 2 raised to the x, we're going to write this as 2 squared is equal to 2 to the x. So now our bases are the same, and we can say that x is equal to 2. And remember, anything raised to the 0 is equal to 1. So in this case, we have x is equal to 0. And this is how we use the laws of exponents, and we solve for x for exponential type functions.